15. Now let's see some question related to chapter 15, reactivity of the metals. And this chapter is very important. Last time in 2024 and 2023 papers, even there were 3 questions only related to chapter 15 about the reactivity of the metals. So you can, and now you can predict that how many questions can appear from this chapter. And only there is one trick to answer such question is that you have to remember the reactivity series. There is no other option for you, okay? And I will give you that what is the reactivity series and how you can remember that one. Okay, to answer the questions related to chapter 15, you have to memorize this mnemonic. And once you memorize, you can easily answer all the questions related to chapter 15 in your exam, okay? This mnemonic will help you to memorize the reactivity of the metals, the most reactive to the least reactive one. So which rows, let's see one question, which row shows the correct order of reactivity of the 4 named metals? So you can see over here, and the most reactive one is magnesium. That is for obvious. Silver are the least reactive one. You can see over here, silver is here and magnesium is here. So magnesium comes first. After magnesium, we will have zinc or copper. We can see over here. Which one is that, right? Zinc is after magnesium. We have zinc, then we have copper, and then we have silver. So you have to memorize this reactivity series. It will be helpful for you to answer the question. So that's why which option is right? Option B is the right option here. Let's see another question. 3 students X, Y, and Z are told that solid P reacts with dilute acid and also conduct electricity. The table shows the student's suggestion about to identify the P. So X, Y, and Z, you can see over here. First of all, graphite never reacts with the dilute acids, okay? So this option has been rejected. Now we are left with copper and iron. Copper is the least reactive one. In the reactivity series, if you see over here, that copper is at the end of the reactivity series. Okay, so it means only option Y is the right option. All those metals that are above hydrogen in the reactivity series, they can react with acid. You have to memorize this one. So if you memorize this reactivity series, then you can also memorize that, okay, all the metals that will be above hydrogen, they can react with an acid, but copper comes after the hydrogen. So it means it will not react with the acid. So only right option is Y. That is C, okay? So C is the correct option over here. Let's see another question. P, Q, R, and S are metals. P react with dilute HCl, forming hydrogen. So it means P will be appearing before the hydrogen, right? Because it is reacting dilute HCl. So you have to look for P out of these one. So now which option can be the let's see now for Q. Q reacts violently with the water. So the top metals actually reacts violently with the metal, that are potassium, sodium, and calcium. Okay, these are the only 3 metals that reacts violently with the water. And the magnesium, it doesn't react with the water, it only reacts with the steam. Okay, so now it means the first one should be from potassium, the Q should be potassium, sodium, or calcium. So can you see potassium, sodium, or calcium? Yes, we can see sodium and potassium here. Okay, so these 3 options can be the right one. Now let's see, for out of these 3 options, the first option, if you see, P reacts with dilute HCl, so it should not be copper, right? The copper is wrong because copper comes after hydrogen. So all the metals that are above hydrogen, they can react with the acid. So now we are left with zinc and iron. So these 2 options can be the right option. Now let's see for R. R reacts with water to give hydrogen. So it means R also reacts with hydrogen. So it means it should be either potassium, sodium, or calcium. Sodium and potassium, okay, we already have a sodium and potassium, okay, or calcium. So it means still we have these 2 options can be right. Now we are just left with one S. S is formed by heating its oxide with carbon. Okay, so S is formed by heating its oxide with carbon. So if you burn it with the carbon, it means you will get the oxide. So it means its reactivity should be lower than the carbon. Only those, and if those metals can react with carbon if their reactivity is lower than the carbon. So which one has the lower than carbon? Of course, zinc. Zinc comes after the carbon, but magnesium is before the carbon. So that's why now you are left with option D. Option D is the right option. So option D for this question is right. Let's see another question. Calcium reacts with cold water to produce hydrogen. Lead reacts slowly when heated in air to form an oxide, but has almost no reaction with the steam. Okay, silver does not react with either water or air. Zinc reacts when heated with steam or produce hydrogen. So what what is the reactivity starting with the least reactive one. So if you look at this one, you just have to memorize. I already have told you that you have to memorize this mnemonic, and then you will remember that which one is the most reactive and which one is the least reactive. So the least reactive will be, of course, silver, because it is here in the reactivity series. Okay, so these two options can be right. Now let's see, before silver, after silver we have, can you see the lead? So lead or zinc, both options can be the right one. But now let's come, who is more reactive, zinc or lead? If you see zinc comes first, so it means zinc is actually more reactive than the lead. So zinc should come over here, right? That's right, because most reactive, and lead is less reactive. And then we are just left with the calcium option, because calcium is the most reactive one. You don't even have to look at these options if you memorize these reactivity series. So you can easily predict the answer, that is C. Okay, so option C is the correct option. Let's see question 57. When zinc is added to an aqueous solution containing magnesium ions, there is no reaction. Which species has the greater tendency to lose electrons? So let's see, if you are adding a zinc and the magnesium solutions, right? Then it means, and there is no reaction. What does it mean? It means the reactivity of zinc is lower. That's why it cannot do the metal displacement reaction. So it means the zinc. So now, which one has the greatest tendency to lose electron? Only the metal that will have those metals that are high in reactivity, they can easily lose electrons. So magnesium is more reactive. So of course, magnesium will lose electrons more easily compared to zinc. Okay. So magnesium option will be the right option, option A. Why not magnesium ions? Because they already have lost the electrons, and zinc ions also have lost the electrons, right? So we are just left with the two atoms, and these two atoms are of the metals. So only these two metals can lose the electrons, but magnesium, because it is more reactive, so it will lose the electrons first. It has greater tendency. So that's why option A is the right option. Let's see question 58. The equation for the reaction of metal M with aqueous zinc sulfate is shown over here. Okay. Which statement explain why metal M react with aqueous zinc sulfate? So if you see here, metal M has displaced the zinc. It means that metal M was more reactive. That's why zinc has been replaced. So now let's see, zinc is less reactive. Yes, that's right. Zinc is less reactive than M, because M is able to accept electrons. Now this word is wrong, because metals always like to lose electrons. So this option is wrong. Now zinc is more powerful reducing agent. Reducing agent means zinc is more easily oxidized, right? So let's see, zinc is oxidized or reduced. If you see over here, zinc, what was the charge on the zinc? It was +2 over here, because sulfate has -2 charge. But now zinc is a metal here. It is in the element form. So now the oxidation state is 0, right? So the oxidation state has been changed from higher to lower. It means zinc is reduced. So zinc cannot be a reducing agent. If zinc is reduced, it means it is an oxidizing agent. So this option is also wrong. Now let's see, zinc is more reactive than M. That is wrong. Why not reactive than M? Because it has been reduced by M. So it means M is more reactive. Zinc ions can remove electrons from M. Yes, this option is right. Why? Because zinc has gained those electrons from the M. It has removed the M electrons, and it has taken those electrons to become a zinc metal. So option D is the right option over here. Question 59. 4 nails are added to 4 different metal sulfate solution. In which solution does a displacement reaction occur? Again, displacement reaction will only take place in metals if one metal is more reactive. Okay, so if there are iron nails, it means the metal which can do the displacement reaction will be the one that has the less reactivity than the iron, because iron is going to displace that solution, right? So any of the solution that has a metal which is less reactive than the iron, it will only be displaced by the iron, right? So let's see which one is less reactive than the iron. So if you see the reactivity series, iron is here and copper is here, right? So copper option can be the only right option, because zinc is more reactive, iron cannot displace zinc. Sodium is more reactive, magnesium is more reactive than iron, so iron cannot displace these 3 sulfate solutions. Only copper sulfate, the copper will be displaced by iron and you will get iron sulfate and copper. So option A is the right option. Let's see question 60. Which statement about copper or aluminium is correct? Aluminium is more dense than the copper. Wrong. How we know that one? Because copper is a transition metals and I already have told you that transition metals have the highest density. So this option is not right. Aluminium is less reactive than copper. Again, not right because the transition metals are the least reactive compared to other metals. Okay, so even if you don't remember the reactivity series for this question, you all should know that aluminium is not a transition metal, so it is more reactive than the copper. Copper has high ductility. Yes, this option is right. That's why we use copper in the making wires. This is the best property of a copper that make it useful to use in the wires. So why we use copper in making wires? Because it is highly ductile. Ductile is the property of the metals to change its shape into wires. Okay, so option C is the right option. D is wrong. Why? Because metals are very good conductor of electricity. So this option is not right. Option C is the correct option. Let's see question 61. Which aluminium is when aluminium is placed in dilute HCl, there is no reaction. When zinc is placed in dilute HCl, bubbles of gas are immediately given off. Which statement correctly explain these observations? So now sometimes the students usually choose that, okay, aluminium is less reactive than zinc. That is wrong. Zinc is a transition metal. Transition metals can never be more reactive than the normal metals, okay? Aluminium is just a simple metal from a group 3, right? So the zinc is not more reactive than aluminium. What is the right answer for this question? Actually, aluminium become less reactive in acids because it has a coating of oxygen. That makes an aluminium oxide, okay? Aluminium will react with oxygen. It forms a coating of aluminium oxide, and this aluminium oxide protects the inside aluminium. Okay, so whenever you place the aluminium in an open environment, it will form a layer of aluminium oxide. So the first layer will be of aluminium oxide and the down one you will have aluminium, and this aluminium will be protected by aluminium oxide. So whenever you see a question that asks you about aluminium reactivity, that why aluminium reactivity is less, the answer is always because it has aluminium oxide layer. Okay, so the first option is the right option because aluminium is coated with a layer of aluminium oxide. Now let's see another question. Iron rusts, but aluminium does not. Okay, you see aluminium is more reactive, but it is not rusting. Again, the same reason, because its surface is protected by an oxide layer. Okay, so you have to choose this option. Let's see another question. The diagram show experiment to investigate the rusting of iron nails. What is rusting of iron? Iron always form a brown color on its surface, and then it can easily corrode. The corrosion of the iron is actually called the rusting of iron. And when it takes place, when there is water and oxygen. When there is water and oxygen in the environment, the iron will easily rust. Okay, so now they have investigated that which option can lead to the corrosion of the iron or rusting of the iron. So the test tubes, which one option is right? This option is wrong. Why? Because we have a layer of oil, so it is protecting the iron. Second, we have already put a stopper here. So the air cannot enter into this one. So that's why the option 3 is not a right option. Okay, so option 3 is not correct. But let's see now here. Salt water and tap water. They are using the tap water and also salt water. So the water, of course, and then it is an open. So it means they both will do what? They will rust the iron. Why salt water? Because the salt water will speed up this reaction. So that's why salt water and tap water, they both can rust the iron. So that's why option 1 and 2 both are right. Okay, why not C? Because the oxygen cannot enter into this one. So that's why oxygen is not present here. And we also have a layer of oil, so it will protect the iron. That's why we cannot choose this option. Okay, so B option is the right option, 1 and 2. Let's see another question related to the rusting of iron. Iron nails are stored in an airtight container. The nails begin to rust after a few days. How can the rusting of the nails be prevented? So the best option to avoid the nails from rusting is that you have to replace the air with the argon, because argon is an inert gas. So if you replace the air with the argon, it will not allow any other element for it, that is water, to react with the iron nails. So that's why B is the right option. Okay, so B is the right option for this one. Let's see 65. Iron rests in the presence of oxygen and water. Which statement about rusting of iron is correct? Now we have oxygen and water, right? So when iron will rust, iron oxide will be produced, yes, but not anhydrous, hydrated one, because we have water. So this option is wrong. Iron rusts more quickly when attached to a piece of zinc. Wrong, because zinc is more reactive than iron, so it will protect iron. Okay, so this option is also wrong. Coating the iron with plastic prevents the iron from rusting. Yes, if you coat the iron with the plastic, then the plastic will protect the iron from rusting. Iron lose electron when it rusts. Yes, that's right. Iron will lose because it's a metal, so it will lose electrons when it will react with oxygen. So option 3 and 4 is right. That is option D actually. So option D is the correct option. Let's see another question. Question 66. Which compound is formed when iron rusts? So iron when rusts, it rusts in the presence of oxygen and water. So whatever you are going to get, you are going to get iron oxide, and that iron oxide will be hydrated one. Okay, so hydrated iron oxide is the right option, not iron hydroxide, because iron will react with oxygen to give you iron oxide, and hydrated because of the presence of water molecules. So option D is the right option here. Don't get confused between hydrated iron hydroxide and hydrated iron oxide. Iron will only react with oxygen, and then there will be a trap of the water molecules in that mixture. So that's why you will get hydrated iron oxide. 67. Which coating prevents iron from rusting? Okay, all these coatings prevent iron from rusting. But the another information, even when the coating is damaged. So when the coating is damaged, it's only the metal that will be more reactive can protect the iron. So there is only one metal that is written here. It is zinc. So zinc is also called as a sacrificial metal for the iron rusting, because it will sacrifice itself by losing the electron first, and then it will protect the iron. Okay, because the rusting of iron can only be prevented by the use of zinc or maybe magnesium. These are the two most reactive metals we usually use to prevent the rusting of the iron. So option D is the right option for this question. Question 68. Which statement about the use of sacrificial protection to prevent iron from rusting are correct? So now you see a more reactive metal than iron is used, yes, as a sacrificial protector because it undergoes the reduction before iron. Wrong. Reactive metals oxidize more quickly, right? Reactivity of a metal means that it can easily be oxidized. So this wording is wrong. That's why this option is wrong. Let's see, zinc is used as sacrificial protector. Yes, because it gains electron. Again wrong, because it loses electron. Zinc is more reactive metal. So more reactive metal means it can easily lose electron, not gain. So this option is also wrong. Copper is not used as sacrificial protector because it is less reactive than iron. Yes, if you look at the reactivity series, the copper comes after the iron. Okay, so it is not used as a sacrificial protector. Magnesium is used as a sacrificial protector. Yes, because it is more reactive than the iron. So it is more reactive means it can easily lose electrons as compared to iron. So that's why option 3 and 4 is right. That is option D. Let's see another question. Metal X acts as a sacrificial metal to prevent iron from corroding. Okay, which metal X does not act as a sacrificial metal to prevent aluminium from corroding? What is X? So it means the metal is actually that metal which is more reactive than iron. It can protect it, but it will be less reactive than aluminium. So you can see the options over here. That is only zinc. Zinc is the one that will protect now iron. Why not magnesium? Because these are copper and silver cannot be the one because they are less reactive even than the iron, right? So we cannot choose copper and silver. They can never be used. Now we are left with magnesium and zinc. Magnesium is more reactive, if you see, than aluminium, right? If you see, magnesium is more reactive than aluminium. So it means magnesium can also protect aluminium, but we have to choose a metal that will not protect aluminium. So zinc is less reactive than aluminium, so it means zinc is the right option because it will not protect aluminium, but it will protect iron because it is more reactive than iron and less reactive than aluminium. So option D is the right option. Let's see another question. Part of a steel ship is protected from rusting using a sacrificial metal. What is a suitable sacrificial metal? So any metal that is more reactive than the iron, right? That can be used. So let's see which one is more reactive. Copper, of course not. Zinc and potassium, they are more reactive than the iron. But why we cannot choose potassium? It is more reactive than the zinc because potassium reacts with water more vigorously. So this is not a safe option. You can only choose magnesium or zinc. Magnesium is not a given option here, so zinc is the right option. That's why B option is the correct option. Let's see question 71. Blocks of magnesium are attached to the bottom of the steel to prevent rusting. Again, let's see which equation is showing the process of rusting. So magnesium will lose the electrons more readily. So you have to see the equation in which the magnesium is losing electrons. So option D is the right option. Here the magnesium is actually losing the electrons and forming the positive ions. So that's why option D is the only correct option over here, that is showing the prevention of rusting. Let's see another question. Zinc oxide reacts with carbon to produce zinc. Which equation represents this reaction? All these equations are right if you see it, because zinc is reduced, right? But if you look carefully to these options, you will see that not all of these equations are balanced. Only one of the equation is balanced, and that is option C, okay? So you have to see the balancing of the equation and you can easily choose the right answer. So option